I have a button to delete OpenCV from GitHub. I also want to build a commercial product.
It's a waste of our resources.
The level of AI fatigue is like the highest I've ever seen in any other industry. Hey, we are an AI tool that's gonna, completely change the way you work every day.
Generate me a person with, I don't know, like 10 fingers.
You either really have a good idea or you are crazy.
Researcher.
Researchers, yes.
We're researchers from JetBrains Research.
Let's try to change people's lives.
Hello, this is JetBrains podcast initiative. Actually, JetBrains Research podcast initiative. And we're here, we are as Igor Slinko and Ilya Zakharov from JetBrains Research. And we have Anna Kogan today as a guest, who is a former leader of OpenCV.
Well, that would be a good podcast for us.
Yes.
Would be a good podcast.
Who is a OpenCV former leader of development, and right now the founder of FitWise, right? AI, the great startup about sports.
Yeah.
So I think we can start from how did you jump from OpenCV to FitWise? Why did you do this? How was your path between these 2 points? Probably.
Yeah, I had a very kind of long-standing dream of building a product. And what I was doing before FitWise is I was basically leading OpenCV.ai, the consulting arm of OpenCV.org, that we basically established and opened to support OpenCV. OpenCV is an open source library, and nobody...
Yeah. If you can tell us a little bit about OpenCV, because
Sure.
I think not all of our listeners know about this.
So OpenCV is basically the standard of the industry in everything that's related to computer vision, meaning analysis of images and videos. Whenever you blur your background on Google Meet, read an image on your smartphone, even make a photo, there is OpenCV code that is actually working in the background. And for that reason, OpenCV is running on billions of devices worldwide. Right now we have 32 million downloads per month in Python, in PyPy. And there are also downloads in other languages and wrappers and from GitHub directly that we don't track as well as we kind of easily do with the PyPy interface. So yeah, OpenCV is kind of the standard of the industry. There is this XKCD meme that, everything is kind of a huge kind of pile of infrastructure in the modern internet is relying on this small, package that somebody does in Nebraska. We joke that we are this package. So,
so we can ruin the internet.
I have a button to delete OpenCV from GitHub. That I can do. I had this button to delete delete OpenCV from GitHub since 2012, I think. But I have never used it. So yeah, that's what OpenCV is. It was started, the idea was came to the brilliant mind of Gary Bradsky back in 1998. Exactly the same year when I went to my first grade. And I only joined OpenCV back in 2011 as an engineer first. Then I was leading kind of the work with the community for some time. And after I founded kind of the startup, I started leading the development work around OpenCV 2. We took the PyPy development work to our team. It was previously done by the community. And yeah, this is how it works. So yeah, that's OpenCV in a nutshell.
Just a couple of questions about the library, maybe more actually.
Sure.
I think we can dive into the startup a little bit further. How did the neural networks influence the library? Is it still this small pile that holds everything, but it doesn't contain anything about neural networks, or it now has something with everything that's going around?
OpenCV supports neural networks, but it does not support training them. It only supports the inference. And the rationale behind that is whenever people do something with images on iPhones or Androids, they often already have the OpenCV distribution as a part of their package. So it would be pretty convenient for them to use OpenCV's inference engine instead of having to import another, library into the distribution. We also partner with several companies who make their hardware to accelerate OpenCV neural network inference on their hardware, and we know it's like pretty widely used by the community. The reason OpenCV does not support training neural networks is, well, frankly, it was very late to the scene. It was back in 2016 when we discussed it, whether we should or should not support training of neural networks already in OpenCV. And it was the moment when PyTorch and TensorFlow were emerging. And we thought that, competing with Google and Meta at that point was, well, pretty brave, but probably not something that we should focus on. So yeah, that's how it works right now.
And is it used? Because in iPhone you have Metal. I don't know where in the layers is OpenCV engine.
Yeah. It's used on ARM devices mostly. I don't think that it's widely used on iPhones. It might be, but it's probably not the most, popular thing to do because Apple's own engine is just very, very convenient and good and supports everything. But for general Android devices and ARM devices that are not smartphones, OpenCV inference engine is pretty well developed. Yeah.
And
yeah, you said that you wanted to build a product, and that's why you are transferring from OpenCV to a new project. And maybe you will tell a lot about it later, but my question would be, why is not OpenCV a product? Why do you not consider it to be a product?
Yeah, that's a great question. Yeah, OpenCV is definitely a product. And honestly, I would be happy to build something in my life that has the same level of impact as OpenCV has. Yeah, it's just very widely used right now. My thinking is the following. I also want to build a commercial product. There were several attempts to build something commercial on top of OpenCV, but the best attempt that worked, there are two attempts that worked. The consulting company, OpenCV.ai, that I built, and there are also courses on top of OpenCV. But the general idea of commercializing the open source library didn't work, maybe for good.
Yeah, for the good of humanity.
For the good of humanity. But I also want to build something commercial in my life. And not because I'm greedy. I want to be rich. But not because of this. I think about money as the measure of something, the measure of value of something. When people value something, they want to pay for it, and you measure it in the, how much money they are willing to pay for something. And in my mind, very successful commercial products are products that basically bring a lot of value into daily life of a person. So I want to find something that has this feature. In the universe of possible ideas, I want to really find something that has this feature that people are really willing to pay for because they value it so much. Yeah.
And it's hard to understand that such a popular library didn't get into it's a perfect example of something that everybody needs and everybody uses, but is not willing to pay. For some reason. So how does it work? Why there is a product that it's much easier to build that than OpenCV, I suppose, but it will gain a lot of money, but the library that is super complicated, everybody is using, is not gaining this amount?
Yeah, that's a great question. Probably I'm asked I have been asked many times, everybody thinks that OpenCV is a multi-billion-dollar company. It has several hundred of developers that are developing it daily. It's not, and it has never been.
What is the scale of employees?
Under 10 developers for the last, at least 6 years, probably the last 8 years, it's under 10 developers. It has been anywhere from 2 to to 8, I think. But that's kind of, you got the idea. Yeah.
Was this scale a limitation from the amount of resources you had, or?
Yeah. Well, it's always the limitation of the, it's the function of the amount of the resources that the library has. Well, it might be that we as OpenCV team are just not doing something right as kind of an open source library, but it's a common pain of open source products. So we are friends with the Linux Foundation. We know a lot of people in a lot of other open source libraries. The only product that I know that has been successful in kind of collecting donations from the community is Django. The Linux Foundation, they find their commercial, they are pretty successful commercially, but they find their commercial traction in completely different ways. So they basically are sponsored by the companies that implement Linux as a part of their commercial products. There are several public companies that were built on top of open source software. Probably Mongo is the most well known, but as compared to kind of every public company in the world, they are just like tiny fractions. So it's like what I'm getting to is it's pretty hard to build a commercial thing on top of open source. And the reason for that is, well, if you can get it for free, why would you pay for it? There are several ways to do that. You can tweak the license so that like Unity did, so that if your revenue is more than some amount of money, you need to pay some amount of money.
But even that change led to a huge pushback.
Oh yeah, we discussed. Like I'll be honest, we discussed it within OpenCV, and we decided that we are never kind of ready to have such kind of to do this to the community. It would be horrible.
If you have been able to hire 200 people instead of 2 or 8, what would be different right now with the project? Or if for example, you are now a successful CEO, you build your own multi-millionaire company, billionaire company, and then you decide to pour some of its money back into OpenCV, what would change? How would the world of computer vision change because of that?
I personally would heavily invest in robotics, and the robotics kind of part of OpenCV. We are also friends with ROS, the robotics open source system. When I started doing computer vision back in 2011, I was like 100% sure that in 2015, I'm gonna own a robot who's gonna do my, house cleaning and laundry. We are still not there. There are a couple
of people promised to do that next year.
That's completely fake. I have a very strong opinion about the startups who promise to deliver the robots that work at home. They are 100% teleoperated. So there is a person in Malaysia who literally kind of, operates this kind of freaking thing in the houses of the richest people in the world, which is like, it's like a series from the Black Mirror. It's like... weird. But anyways, so we are still not there in terms of the robotics, and I don't feel that we are gonna get there in the kind of next 5 years. So I would heavily invest in the robotics part. That is very kind of cohesive with the OpenCV distribution currently. Yeah.
Maybe it's time to tell about your project that you're investing in right now.
Yeah. It's a pretty weird story, to be honest. So yeah, like I spent my whole kind of professional career in computer vision, and I'm kind of a computer vision geek. I met my co-founder as a part of the same team. We've been working together for 12 years, like doing this. And then in 2019, when we were doing our first company together, we started working, like it was a services company, and we started working with worked with many industries, right? So like manufacturing, medical, many. And then in 2019, it was the first time that we started working with sports. And I remember before our first call with a company, we were like both very excited because we finally found an industry where data is not the bottleneck. Everywhere else, it's like really hard to collect data in like In the surgical room, for example, it's like almost impossible to do that. But in sports, it's abundant. And I remember I asked, like, guys, what do you do with the data? I imagined like there is a huge pile of, data that you can work with and annotate and do anything. And they were like, we just remove it because we don't know what to do with that. And I was like, what? And I thought it's maybe like these guys and everybody else does not do that. But, well, I was
It's just
wrong.
cheaper to remove it.
Yeah, I mean, there is loads of it and it's unused. And it's a weird kind of combination of two things. So despite having an abundance of data, the AI penetration in sports is like super low. And most of the data that sports operates on comes either from sensors like wearables that athletes wear during the trainings and during the big games, or from manual data annotation. So there are teams in Egypt or Malaysia or Philippines or you name it. 5 people watch the same game from start to finish, and they click when there is a shot. In every other industry I have ever seen, they were in this phase. They used sensors, or they used a lot of manual data annotation, but they stopped because AI replaced it. In sports, it's not the case, and I don't see that it's going to be like I was watching this industry for many years. Like in 2019, we started thinking about this, and it's still there. So this is the reason why sports. It's like a very, I would say, geeky. Like my co-founders, it's a geeky way to look at an industry as outsiders. So we are completely outsiders to sports.
So you want to really disrupt the field from outside.
I watched this interview with Larry Ellison, and he says that, if you have a good idea and you come to a person like from this industry and tell it, they typically tell you that you are crazy. And there are 2 reasons, the 2 possible options. You either really have a good idea or you are crazy. And I'm exactly at this point right now. So I might be, not knowing enough or be silly enough to think that I can actually do that. But for some reason, for many years, I'm already like in this industry. I still think that it's possible. So yeah.
You were saying that data is not an issue, and really our world today is the world that is starting to be built on data more and more. What does this perspective of the abundance of the data gives you in terms of the ideas on what to use it? Like, first of all, what do you actually want to get out of this data? And second, given that there's so much data, how do you approach it? How do you approach this abundance? Because, well, people who have tried to work with a lot of data understand that to have a lot of data is not enough. You need to have ideas, you need to have hypotheses, you need to have research on that, and we will definitely be asking questions about this perspective as well. Well, to start, you have data. What to do with it next?
In sports, most of the people who work in sports, they are like pretty conservative, I would say, about adopting new technologies. And there is like the level of AI fatigue is like the highest I've ever seen in any other industry. So they also have a lot of, cold messages on LinkedIn saying like, hey, we are an AI tool that's going to, completely change the way you work every day. But it does not change the way they work. So they still have to, have the athletes run back and forth like this amount of times and then do push-ups, pull-ups, stuff like that. So what they actually care about is winning. They have too much data already from sensors and the manual data annotation that they frankly don't use. So what they are looking for from like a possible tool they're going to use is very high level analytics so that they don't have to dive very deep into, how many steps everybody did.
Maybe this is a problem. To get this high level analytics, you need to run it through the human.
Yes and no, I would say. In many cases, nobody still knows why somebody is successful. So take Messi, for example. every like 6 months, maybe 8 months in sports, there is a new kind of idea why Messi or like some other player is actually a good player. And the most like, it's probably not the most recent ones, but one of the recent ones is that if you look at how Messi plays, when he gets the ball, he does not shot it right away. He doesn't shoot it right away, as many young players do. He actually first rotates his head and does what they call field scanning to understand kind of the strategic position around them, and then makes the choice, right? So he's very strategic about his moves.
It's a current hypothesis.
It's a current hypothesis, yes. So what I'm getting to is, first, nobody actually has the data on like every head rotations of every player in the field. So they have to kind of guess. Second, it might not be the right idea at all. And the data geek in me says that the right way to kind of understand why Messi is a great player is to actually analyze a huge amount of data, historical data of him and maybe other players, and find some specific features, traits that he does versus everybody else. And maybe after that, there will be a kind of data-driven way to find a young athlete in Argentina or Chile or Peru, or you name it, who does exactly the same thing just naturally. But
you just need to...
Research in me says that you need experimenting for that, not just data. Data is not enough. You need to build hypotheses from data and then confirm it in, falsificate it in an experiment. So just having data wouldn't be enough.
It's before Transformers age. Now you need to gather a lot of data, run it through LLM, and it will give you the vector of Messi. Then you like compare it with another player vector like cosine-wise, and you get your new Messi.
The problem with the scouting of young players who are 9 years old and playing in Argentina is you cannot actually run the experiment and wait for like 20 years until they become the superstar. But you can maybe do something on the historical data. So might be good enough.
So do you approach this question of going for this high-level hypothesis by yourselves as data people, or do you consult with experts in the field? Do they help? Actually, this question is really important for a lot of industries right now. Trying to use all the data to increase performance is actually more or less the same thing as JetBrains, and JetBrains research is also interested in. And here's what we can see is that the way people from outside approach work of something, developers, for example, can be very different from the perspective of people inside the field. How does it work for the field where you are not an expert? How do you work with experts who are already in the field?
Yeah, that's a great question. First, it's a pain. It's, the typical situation when, two geeks come into very specific kind of very, well-established industry, and they come and they say something like, well, we are going to disrupt you. Very arrogant way to do things. So we try to be self-conscious about the fact that we are not experts in sports. First, we typically work with the sports tech companies who actually understand something. So we basically do these 3D full digital replicas of the games that happen and training sessions that happen. And then they do the second layer of the analytics in their respective sports. So for example, in American football or like tennis. Second, we work with the consultants from the industry, people who worked like many years in like Manchester Uniteds of the world, or like Chelsea's, or other established sports organizations. So they basically spend their whole life there. And sometimes the things that they tell us are shocking, because we frankly are not from this field. But we work with them closely to actually immerse ourselves into that.
How does it differ from your previous experience with OpenCV? So you've been working with a lot of data there. You're working with a lot of data right now. What is the same in the way you approach getting new knowledge, and what is different for you in the ways you try to find out how things are working in front of you?
I would say just from the resources standpoint in OpenCV for the last I don't know, many years, we've been kind of reactive. So community would tell us something, we would address it, or we would wait for for somebody in community to implement it and help them, guide them through actually making it part of the official code distribution. That's it. Whereas in a venture-backed startup, you kind of have the freedom to dream about things that do not exist in the world, but at the same time you have this danger of creating something people don't need, in fact. Something that venture startups are famous for. So you always are kind of balancing on this between these two states, I would say. This is from kind of the data and new research perspective, I would say. From the kind of product perspective, I would say that we are kind of the same thing kind of happens in this kind of product realm too, because OpenCV has an immense product market fit, so you basically need to make sure that you don't break things and just keep them intact and that's it. In this new thing, we almost don't have a product market fit, right? So we have customers, but it's a tiny fraction of the market that we eventually would love to address. So we need to kind of fantasize and somehow kind of offer it to the market, get the feedback from them, iterate on it. It's like these are two very different mindsets, and I'm struggling to switch from the mindset that I used for the last 15 years to this new kind of venture mindset. I'm always kind of have to be self-conscious about the fact that, well, that's what I need to do, not.
Maybe since we're already speaking about FitWise, maybe you can tell what exactly is this company doing right now, so we can then transfer a little bit to the actual approaches, the research, and how do you deal with this? For example, from what I understood, you work with top tier leagues, as I understood, like Manchester United is, and with the top sports like American football, soccer, I suspect. Do you work with already existent material, or you put your cameras, for example, there? What is the whole overall thing? How all this thing work?
So yeah, we take broadcast footage of American football or soccer. I always need to think about the person I'm speaking to, because it's either soccer or football, and I can offend somebody by saying soccer when it's actually European football. So yeah, that's funny. But right now, two sports that that are our major focus. We take the broadcast footage of them and we turn them into full 3D digital replicas, where the people are represented by actual bodies, the kind of biomechanical models of the bodies, instead of the representation that is common for sports, which is a single dot per person. So these 3D bodies, they move and they replicate the movement of the actual person there. And the whole thing kind of allows to, look at the game from the bird eye view, look at the movement of a specific person, or see how the goal happened from the eyes of the goalkeeper or the striker. That's kind of it in a nutshell.
And this broadcast is the broadcast we see on the TV, right?
Yeah.
So with the camera moving.
With the camera moving. In soccer, this is the broadcast that we see on the TV. In NFL, we prefer to work with the data that does not have the scrimmage lines and the logos that are superimposed in the production. Just, the footage that goes before, applying the sponsor logos on the footage. But that's it, yes. All the cameras are moving all the time. So from the computer vision standpoint, it's definitely the hardest problem that I ever worked with, and my co-founder Tatiana also worked with. It's incredibly complex because everything is moving. The resolution is still very underwhelming. People are wearing the same jerseys except for the numbers. So it's and they're also moving very fast. So like everything is pretty complex from the computer vision standpoint, but I mean, our OpenCV kind of heritage allows us to kind of address this in a way that we hope is the industry standard.
Mm-hmm. Yeah, why I'm asking, because I was working in, I think, the same, not the same idea, but also with we had the still camera. This is the only thing that we had different, but we still needed to do the whole pipeline of steps, like to detect every player, the ball, the puck. In hockey, it's nightmare because the puck, 90% of the time you don't see the puck, so you need to calculate where it is based on the previous position, and to do 3D bodies from this, very interesting. I like. When I hear such things, the first question I have is like, okay, now you have these 3D bodies moving. So, and you say that there is like next step of the pipeline, which is not on your side, like people get this representation and they try to analyze something on that. So this is, I think, the hardest thing, to like get some new information with these 3D inputs. You have a lot of data now, and how do you transfer it to something meaningful? Like there should be a data set, there should be the huge pipeline that tells you like how this huge amount of concurrent data comes into something, some insights on the field, and you're not doing this. This is this is a good part, I think. And how did they like do it before you came? So they had also these 3D bodies moving, and also like how do they do this next step, if you know?
Yeah. I have many answers. So first, our current customers, yes, we just supply them with the raw, we call them raw, like 3D replicas of the game, and they extract the specific information that they're interested in. So for example, they can calculate the angular velocity of the arm of the quarterback when they are doing the throw, because it turns out to be like a very important feature of like the best quarterbacks, and we know nothing about this. That's the idea. We are happy to have the customers who actually know sports better than we do. But on the other hand, we understand that we also need to do something with the data to make it more consumable by our clients and customers. And we compute this. We started, turning this data into analytics ourselves too. And we kind of had a choice. We could either replicate the information that this market already has, the information that comes from the sensor data, or like from manual data annotation, or we could, annotate, find some new things. And right now, again, because we are like venture-backed startup with this mindset of building new things, we first want to address this second thing. We specifically focus on the features related to biomechanics of the athlete's body, something that was not available with the data that is commonly kind of used in the market. And we find things like fatigue markers, things like the situations when somebody is too fatigued to perform at their best at the field, which may lead to some bad outcomes for them or for the team. So these are the things that we are currently working on. We also implemented obviously some simple things like speed, acceleration, and stuff like that. Yeah, that's it. He also said that we are working with top leagues, and top teams. We have design partners from the top teams, which means that we are working together with them, understanding what is that they actually need in terms of the biomechanics of the athletes. But our customers right now are the sports tech companies, so the companies that at the same time understand, speak the same language as we do, but have the understanding in sports that we lack.
I'm not sure that this question is not going into a wrong direction, but so the sport is maybe one of the things that is surprisingly well modeled. Not only the real world sports is there, but also there are a lot of sport games, and there is the whole series of games for different kinds of sports, where you also have some kind of modeling, some kind of data on how do people play sports. Does this helps in any way approach in the real world, like all these models that we see in computer games? Can this data be utilized for work you're doing?
Yes and no, as always.
For sure.
The data that we work with, kind of this 3D biomechanical data, is like super hard to annotate from the real life games. We found that humans are like very bad actually from like in the task of fitting a 3D model into an actual body of an athlete, especially if the resolution is not very high. So it's like subjective and cognitively hard task to do. So the only way to actually collect a precise data set of like running people in soccer or American football is to simulate this in a very big kind of on a rendering machine essentially. So this way you could change the jerseys, the lighting, you can put snow, you can put grass or like turf, that's okay. So we extensively use that. On the other hand, it does not help the algorithms themselves. Yeah.
And like about the progression of technology, like there is like very big progress recently mostly in NLP, but also with the transformers to the computer vision. Like how does, like I suspect that in computer vision is the same. So like every month, every half year you see like next competitor on the, I don't know, the task that you're working on. Like you have the whole pipeline of tasks, like from detection to 3D modeling, and like how does it change the way you work? Like today you work on this algorithm, tomorrow you just change it, and you need to be able to like move from one wheels to another wheels on the fly. Like that, is it different from what it was before, or it feels the same as before? Do you feel that do you feel the product safe, meaning that tomorrow there will be some tasks already solved that you're trying to solve?
Well, you're never safe when you're building a startup. It's like you basically always know that there are competitors. Some of them you know, and you're lucky to know them because they're public about like what they are building. But you are, like, frankly, I'm more scared of the competitors who are not public about this. But there are huge companies in our industry that have like many orders of magnitude more resources than I have to build pretty much the same solution. And I know that they're working on it, but I don't know what their results are because they're secretive about this. On the other hand, it's really bad when you don't have competitors, because in some cases, it means that you are creating a Google. And you are the first to do so. But in 99.9% of the cases, it means that you created a problem that nobody actually has. So it's good to have competitors. That's what I'm saying. You need to have grit. I think you don't need to. You don't want to change your direction when you hear about new competitor emerging. Yeah.
The question that I would like to ask from the point of view of the research. So you're building a lot of interesting technological solutions, and one thing about competitors, they are companies who are also building these solutions. But how does research do in this field? Like, do you see any published work? Do you see that some people from academia worked on these tasks, or is this out of scope for people who are trying to work from I don't know, particularly from fundamental science perspective?
No, yeah, there are papers, there are companies who are not focused in sports. For example, RoboFlow, they have this fantastic person. I love reading his posts. His name is Piotr Skalski, and he basically creates a lot of samples for like that use computer vision models on sports. But the like business of RoboFlow has nothing to do with sports. So there are companies, there are labs, there are just researchers who focus on applying computer vision to sports. There are companies who actually focus on sports and they also publish papers. It's like pretty rare, but it happens. The thing that I see in like the realm of computer vision papers is like whenever there is a new exciting area in the industry, it kind of, you know, all the people from the adjacent industries, they kind of switch to working on this new cool thing. And right now, computer vision is not cool. LLMs are very cool. So I see a lot of people switch from computer vision to LLMs, and this kind of leads to like us computer vision people having less papers. That's what I see. Yeah.
That's also what I think I see on the job market. So
Yeah.
there are few vacancies on computer vision. There are a lot of LLMs, and I was wondering, like, do you think it will like change?
Yeah.
After, I don't know, what should happen so CV will become great again?
You know, there was a time when CV became so cool that it was the industry that was kind of sucking brain power from everything adjacent to it. There is one thought that I wanted to share. Like Ray Kurzweil, the futurologist, he wrote this book and he says that he was working on machine learning for like many years, starting from 80s. And he noticed that whenever there is a very new cool thing that nobody actually understands, but everybody wants to kind of implement or work with or something, it's named AI. But when people start to understand it, it's not AI anymore. Something else is AI. So there was a time when computer vision was AI. There was a time when LLMs were AI. But now they kind of are more and more treated as LLMs, and then there is some new AI that's going to emerge.
That will be there.
That will be there, yeah. So I'm not sure whether it's going to be computer vision. There are some, you know, smartest brains in the world, like Fei-Fei Li, who say that this is going to be related to, like, the real AI is going to be actually related to our, like, understanding of the 3D worlds. I'm not sure we're going to see. I don't know.
You were saying that, well, first of all, I didn't read it, unfortunately, the paper that showed that for well-known ARC benchmark, which is one thing that will show us that this is AI already, that probably some computer vision architectures might be more relevant in approaching this benchmark, in solving this benchmark than LLMs. So probably CV will do that again. But my question was about robots and the part that you were saying that with the future might be lying somewhere there in robots. Can you maybe tell a little bit more about these world models, 3D? How are they approached from the point of view of computer vision? Do you use something like that in your plans for data analysis? Does it somehow related to world models that people are talking right now?
For coding.
Not only for coding, for everything.
Yeah, actually, I think it's a good analogy because, like, right now we are working on code a lot with LLMs, and there are world models that emerging in code scenario, but there are already a lot of world models everywhere aside of code, and that's interesting. Like, what should we expect in code in the future? So if you can tell us a little bit about like these world models that understand everything, I don't know.
Do you plan to build world model of sports with any of your models, or how do you approach? Do you approach it thinking that there is some intelligent model behind your approach, or is it just solving particular tasks without that things about clever machines doing that work?
Yeah, I'm sure that at some point, what we do in sports is going to be solved by VLM. I hope we are going to be the people who build it. Maybe there will also be other people who build it. But at this point, we're not there. So the way that we approach these algorithms is just we split it in two parts. We calibrate, we detect people, we do pretty boring computer vision stuff. And the thing is just, to do it well. It's not to create a new breakthrough algorithm. Well, I don't know, like I have no crystal ball, but from my 15 year in computer, I mean, I feel a bit too old, but so I've been in like AI, machine learning, computer vision, you name it, for like many years. And what I notice is there are kind of two types of cycles in everything. There is a tick and talk, Intel and then Apple, they adopted this strategy of first doing a tick release and then talk release. So there is a tick phase when everything grows, maybe exponentially, and there are new scenarios where something is applied. It happened to computer vision, happened to LLMs. At some point, this growth stops, and there is a plateau where talk phase happens and everything starts going to the edge devices. Right now, we are in the tick phase, I believe. But we already hear about, attempts to run LLMs locally. So I think that the next several years are going to be around that. And I also think that the development of the LLMs and adopting them to new scenarios is going to I think it's going to plateau a little bit. I also don't think that we are already at the edge AI phase just yet. I think it's going to be, the next ticks that we are going to see, maybe one, maybe more, I don't know. But that's kind of how I see the current phase. I do believe that at some point we are going to see the world models, the models that actually can perform in very, very big environments, with a lot of variables. And robotics is one of the problems where the environment is incredibly big and the variables are just everywhere. And this is why I think it's going to be very hard to solve. I don't think that the current algorithms are there yet. And I think that it's going to be the next tick phase that is going to solve this.
So we're not waiting for Messi?
Not yet. There are already there is robotic racing, there are robotic fighting, but when you look at it, it's more fun than actually replicating the human level of performance. So yeah.
But do you plan for your data that you work with to be later used for building these robots?
No, we are purely our thing that we are solving. Right now we are focused on sports and professional sports, but in general we see ourselves as a company that solves human movement, because for some reason, we have 8 billion examples in the world of humans and they move, but we don't know much about the movement, which is weird. I read a lot of PubMed papers trying to understand how people fatigue during the games, how they move, what is different between a movement of the person who is injured versus not injured. There is obviously a lot of science there, but as compared to the science that I'm used to reading in computer vision, frankly, I don't want to be this arrogant person that kind of comes to this industry, but it kind of feels basic, to be honest. So there is this hamstring injury that is the most common injury in professional soccer and also American football. And science knows a lot of things about hamstring injury. So the biggest predictor of hamstring injury is whether somebody already had a hamstring injury.
Sounds logical.
Which is important, but well, there's probably more to that. So that's what we want to solve. It's not about the robots.
And since you started about the research, like, do you read research papers now? Like, is it possible to run a startup as a founder and also read research papers at the same time?
I have cursor doing this for me. So
But you
please
do
cut
it
that.
like
Please cut that. I didn't say cursor.
there is nothing to be shy about. I do
Sorry.
the same thing with ChatGPT and Claude.
Claude, yeah. I have Claude doing that for me. Well, I kind of try to build this environment where, I don't have I don't have kind of this as a part of my routine where I read papers. Because we're trying to solve things related to biomechanics and human movement and other things, I now find myself reading more kind of PubMed papers or like biomechanical papers or sports papers than I do algorithmic papers. But Tatiana, my co-founder, she obviously reads more technical papers. Since like the AI became actually smart, the thing that I do, I try to build an environment around myself where everything I know is a Git repo. So I believe the text is more important than the tool. So I need to have my knowledge in a text in a very neat, organized way. And then there will be an LLM that can read a paper for me and correlate it with what I already know and highlight some new things for me. So that's what I do, yes.
Yeah, I mean, like, I think the efficient way right now, since like the papers are coming more and more and the conferences are accepting more and more papers every year, then this language of paper will be translated to our difference of our knowledge, right? So
Yeah.
it's a logical part of the process. About the research, you mentioned that some of your competitors, startups, do release some papers, and I wonder, why do they do this? Like, why? Like, the basic question is like, why do people, in general, release the paper? So we have the job to release the paper. We're a research department. We have our reasons to do that. But what is the reason for the startup or for the big company to release papers? It's something. Why do you think they do this?
Well, sometimes it's like a startup partners with a research lab. But the research lab, like they actually pay for the research. The research lab is only willing to do that if the result of it is a paper that they get, they want to publish. So they, for example, build a data set that is non-commercial for everybody except for this company. This is the structure that works in many cases. Some companies publish to attract talent, because for like new PhDs, it's like really important to have an ability to publish as a part of their work. I would say that like publishing the core results of the work was like much more common in like 2021 or 2022, when the VC money were much more abundant than they are right now. And it was more important to attract talent as fast as possible than, hold your secrets very close to you. But still right now, like attracting talent is important enough for companies to publish the results of their work. Well, and the last thing is obviously patents. So they want to patent the work that they do and they need to publish it. But sometimes it comes with a kind of, you file a provisional patent and then you publish paper around that.
Have you seen any difference on like how do different parties approach the research, like corporate, startups, academia, what else? Open source projects like OpenAI. Oh, OpenAI. Oh my God, I did it again.
It was an open source project.
It was, yes. But they did publish papers. I read one of the recent papers of OpenAI, which was like open research paper. It was like, I think, 60 pages. I understood like very little of it, because like I think it was intended to be very complicated to read. So we have a paper. It's like about some basic research. Yeah. It's super complicated to read. I asked many of my friends, they also failed and deeply understanding what is written there, but the paper was published, everything is good.
Anthropics papers are the best.
Mm-hmm. Yeah.
Yeah, like of course there is a very big difference between the kind of styles of work. Very few startups publish. Because they just don't have enough runway, frankly, to spend it on publishing a paper, because a lot of work comes into publishing a paper. And whenever they do that, it basically means that they need to achieve a very specific goal, like hiring. Whereas for a big company, it's just a part of the routine kind of process. They publish, and it's like a machine that works within the company. They always have to publish. And for that reason, the research from the companies is typically of much higher quality than for a startup. Because for a startup, it's typically one-off. The open source orgs, well, they publish very rarely. And when they publish, it typically is sponsored by a corporation and is done together with a corporation.
Why do they need these publications? I mean, open source projects. So we've discussed the ideas behind publishing for corporates and for startups. For open source communities, what is the reason for publishing? Why do people do that? And how all these different ways of sharing knowledge affect the technologies in these different spheres, in corporates, in startups, and in open source? Or it doesn't. Maybe it doesn't affect technology at all.
I feel that when open source publishes, and it's typically done together with a corporation, it's just to get people to know something. We as OpenCV, we struggle like very much to kind of educate the community about not even the new features. So in OpenCV, in the first version of OpenCV, there were the image formats that were completely erased in the second version of OpenCV. That happened in like 2012. We still have people who use the first version, which is crazy. Because, well, we need to support it. We need to address the tickets or like bugs that they send us, which is like, it's 2025, guys. So it's like really hard for an open source project to educate everybody on the new features that actually happen. When it's done together with the corporations, so for example, there might be a new optimization that happened for like these devices. The open source team really wants people to know that they should switch to this new version and enjoy the acceleration. The corporation wants to make it a press release and then have like watch their stock go up, and yeah.
Sorry, I'm jumping between topics. Now I want to jump back to multimodal LLMs.
Yeah.
Because like I'm thinking about that in CV, you can still do science, you can still train models, you still can solve the small tasks one by one, gather the data set, like train and see the metrics. But I think in NLP right now, like most of the companies that do in startups, they do not train the model. I even do not think they gather the data set, and they maybe calculate some metrics, maybe not. And in computer vision, you still have this, and it's fun. And it might also die with the multimodal LLMs when the LLM will understand better what's happening on the field, better than the model specifically trained for that. Do you think it will happen soon? If it will happen, how, like, what would be the science of this? Because like I see some science already like many years ago, and it's still not there. Like you remember, like you had this podcast 3 years ago, and in that podcast you said that it's fascinating how you put the image into the VLM at that point of time. I don't remember which was, but it understands what's happening. It understands the relation between objects, and it's something that is really hard to train. Like you need to train specifically for that, and it's many years from that time, and still we have. Networks that are trained to do specific tasks, and they are working better. But in some fields, the VLMs are unbeatable. For example, OCR, I think, is better solved right now with with visual LLMs than specific models. Maybe we are getting there at some point. I don't know, about the detection overall.
Well, I'm 100% sure that at some point VLM is just going to solve everything in computer vision. I'm not as positive though about the timelines. It might be because I've seen a lot of things that were going to completely disrupt the science as I know it. For example, in 2016, Google released AutoML, and there were a lot of people who said that nobody's ever going to train a neural network manually again. And I was scared because this was my job and I loved it. But it didn't happen. So it might be that I kind of, watched it all over again, and I became just overly skeptical towards the progress. And it's also a bad thing because at some point it's going to happen. But I'm not as optimistic about the timelines. I don't think that it's going to happen in 2026. Maybe in 2027. The science for it, I think the video generators are the closest things right now to having a world model in them. So when we are able to generate a 5-minute sequence without it having some obvious mistakes in it of a very complex thing, then I think that we already have a thing that understands the world well enough, and we now only need to kind of extract it, maybe interpret, maybe extract the information from it in some way. Some school of thinking says that it's not the video models, but it's the 3D models. I think they, frankly, both, to generate a good video, you need to understand physics and the 3D well enough. So I don't think that it's that important. However, I remember then. So there was this story on a chat. Somebody asked me a couple of years ago, when do you think we are going to have a model that is going to generate a minute of video that would be perfect? And I said, it's going to be 3.5 years. And then 1 month from then, OpenAI releases Sora. And I looked very bleak then. Everybody just saw that I'm overly skeptical. But they just released Sora just to kind of, show the kind of cherry-picked sequences. When people actually started playing with it, it was full of, small, tiny, or maybe not even so tiny mistakes. So I'm talking about the point when we actually watch a thing and it's perfect. And I think it's going to mean that VLMs are good enough.
I think here is a good analogy between cherry-picked videos or videos that you see generated by Sora or by other competitors right now. And there is an analogy with the automatic self-driving cars, that you can easily train, and it was done back when Google started the project with autopilots. Many years ago, I think it was 15 years ago, and you can easily train a car to drive through a small town in the best conditions, where you have all the signs, all the people correctly recognized. It's easy, and then you have this huge tail of corner cases that you need to approach. And what models generate right now is this golden path. It doesn't show you these corner cases. You see them sometimes, yes, but this is why it's hard to guide it. You say generate me a person with, I don't know, 10 fingers. It's hard to do. It will generate with 11 fingers probably, because it doesn't have this in the training data maybe. But these are the corner cases that we do not see when we see the generated videos right now, because the videos that are generated right now is a golden path, and the model is trained to do good. But if you try to go left and right, you will see where it fails. And that's why even if it's seen as a good 5-minute video, you do not know what the model cannot generate, because it doesn't generate you this.
There is this gymnastics test.
Yeah.
I don't know about it. Please tell about it.
Whenever there is a new release of a video generating model, people ask it to generate gymnastics, and typically the results are scary. I have only seen one model, and it was VO3 that was good at that. I didn't play with it myself though. I trust the results from the internet. I might be too silly to do that. But so far, all the other models, they just, go crazy there. And it also kind of correlates with my understanding of sports. So as I said, sports is the hardest problem that I ever worked with in computer vision. And video models are also struggling with that. So it's kind of correlated.
Even given that probably in the data, there were a lot of examples like that.
Yes.
Exactly.
A combination of moving camera, a very weird, looking person who does these crazy things.
Do we have enough data for solving sports? You are saying that, well, the data is not a problem, but given that complexity and given some estimates that, for example, for LLMs, the internet was not enough. It's already finished, trained on it, and now we don't see progress because we've reached the peak because the data is finite. Can it be the same with this kind of problems that we just don't have enough data, and maybe we need to generate it for several decades more with very strict labeling and all that stuff to be able to solve complex problems?
We need to define the we.
Society.
Society, yes. The problem with the sports data is that it's very, if we are talking about the top leagues, it's there are media right holders that own the rights on this data. So in most cases, even the video LLMs were not trained on it because they just cannot access this data. Surprisingly, even now, in many top leagues, for example in NFL, the video is just 720p, which is well, it's 2025, guys. In many European soccer leagues, though, it's already 4K, but it has been 4K for a couple of years. So we definitely don't have enough high-resolution data that is available to the models to train on. But I think we are heading there for sure.
I think in a way, Igor already asked something like that, but given the problem that at some point, these good big models can solve a lot of complicated problems. And you are building right now some, I wouldn't say temporary solutions, but well, in a way they are temporary solutions. How do you approach this? How do you see this danger in the possibility that in 2 years VLMs will be good enough to give the answers that you've been building for years just by one prompt? So how do you approach growing in the world that is changing so fast, where technologies are changing so fast? And maybe you have already seen something similar in your experience already, like that technology and some solutions became obsolete because of some powerful, bigger models that maybe were not even trained for that.
Yeah, again, my bet, I might be too pessimistic. I might be even overly optimistic, I don't know, is that for the next 5 years, we are good with the current stack of the technologies that we are using for our solution. The thing is, okay, so in 2019, I was visiting a web summit in Lisbon, huge conference, 70,000 people. Everybody was talking about AI. And I was kind of, wondering there and thought that, all the problems are already solved. But when I worked with, specific customers, from industry, they had zero automation still. And up until now, there are a lot of companies. So for example, if we're thinking about like plastic waste, right? In Europe, in the US, in Canada, there are huge facilities where, the plastic waste, like all the plastic bottles from, specific state, they go all together. In many of these places, still people are doing it manually, even though obviously there are algorithms that can recognize the plastic bottle. There are robotic hands that can grasp it and that can put it into the bin. But the adoption of technology into some real world scenario is like super slow. This is also the reason why people are talking about AI bubble right now. Exactly it, because we already have the technology to like automate some part of the human work. Nobody is doubting that. But what is kind of different between the reality and the expectation is the speed of this adoption. The same thing is applicable to the industry I'm working at, and probably to like most industries that we know as humans.
Yeah, probably the industry that you are working right now and we're working right now is adopting things even faster than in average, maybe several times faster than an average.
Yes.
So basically, you're not afraid that the technology will be obsolete even in 5 years. That's actually soon enough.
No, I'm not afraid of that. Well, like the first reason, I don't think that there will be some magic box that will just automatically solve the thing that we are working on in like several years from now. I think that the best shot is actually the pipeline that we built internally, or something similar to that is the best shot at getting the same result. But the reason I'm not afraid of that is it's true for sports. It's most probably true for many other industries, if not all. The biggest problem is not the technology. It's the adoption. It's actually understanding what do the sports scientists do daily in their work, what are the buttons that they are clicking, what they are looking at. And even though, well, some of the technologies that we're implementing as a part of our solution have been around for like several years, some not. But we have not seen a startup who have been able to grasp all of them together and implement it as a part of the life of somebody real.
And talking about adoption, the example of people using OpenCV first version from 2012 in 2025 gives us some hope.
Yes. I know people who implement OpenCV as a part of the software stack in the seven, like in some of the seven kind of, there are this S&P 493 and S&P 7. So there are 7 companies that are basically driving the growth of everybody else. So I personally know some of the people who implement OpenCV inside their software stacks. And the version that these companies are using is lagging like way behind our public release. So that's just the way. It's not that they are not innovative. It's just hard to adopt something when you already have a lot of things implemented on top of that.
I just remember that like in that startup, the sports startup I was working with, the biggest problem was to get the acceptance of our technology to put, like, we actually gave everything for free or almost for free. You just need to pay under 200 euros total, like for sure a month. So the telephone contract is cheaper sometimes in Europe, and we will install our camera. We will everything will be working. If something breaks, we will come and fix it, and you will pay for this really small amount of money, and you will have your recordings of every game you play there, and you will have the broadcast of every game that you play. And still it was really hard to convince people to buy this. One part of it, it was not like top tiers league, it was the other way around, the down league, and they didn't say why do we need the recordings, like we can just watch it. So Yeah, but it was super hard to convince, and I suspect in the industries like waste industry, it's also like this. They have this like huge magnet that they installed like 10 years ago or 20 years ago, and that generates the majority of money, just taking out the metal things out of the pile. Why do you need to do more? Why do you need to sort this plastic? And it's interesting because like I remember people saying, okay, the waste industry will be solved like in a year because we see these robotic hands, like OpenCV is working, and still we hear the same thing. And I see a lot of reels, TikTok from India, where people like taking this bottle, they put it into some very scary machine and make it a pipe or something. Yeah, just some thoughts. You wanted to...
No, I'm just thinking, the question I think I have is coming back to the beginning. So when you've started to talk about this new project, you've said that one thing to consider it was that it doesn't have this data bottleneck. How in general do you approach new fields where to go right now? One thing you've told the data. Just in general, what are your thoughts behind choosing the problem to solve?
Well, I don't want to turn myself into, the quotes of famous people or style. But, well, you need to genuinely love the thing that you are working on, because we work, we work at least 8 hours a day, right? Sometimes more, sometimes less, but still kind of something. Like, that's a lot. That's 1/3 of our life. And it's just dumb to spend it on something you hate or are not excited.
I never thought that you're into soccer and American football in particular.
I'm really fascinated by this thing. Like, I believe that there is a science behind how people move. There is a personal story behind that also. I'm fascinated by the the amount of data, the sheer amount of data in sports and everything. But I'm really fascinated, as I said, by this human movement part. So 2 years ago, I broke my spine pretty badly, and there was like 10 to 20% chance that I'm not going to be walking ever again, or even feeling my body below my waist. So I got into the hands of like a fantastic doctor, and they frankly saved me, and I'm able to walk and do everything. But when I was recovering from this for like half a year, I knew that I need to do a very specific set of exercises, so that very carefully I restore my muscles in my back. But well, there was no science, no guidance, and no trainers who were able to help me in this journey. I read about several startups and companies who focus on just providing very basic feedback to people in physical therapy, and they are growing like crazy. There are several companies like Omada Health, Kaya Health, Sort Health. They all are unicorns, and they are just providing very pretty basic feedback to people who move and who have pain. So I think it's pretty weird that we have humanity focuses on generating nice pictures, movies, and everything. But whenever people have real pain in their body, they don't have guidance on how to heal it. And I believe that the reason for that is, well, basic lack of science behind the movement. So for us, sports is just like a way to enter this, realm of movement. But we aim into bigger coverage.
Any other ideas besides sports, where you want to go further with this approach of understanding movement?
Like sports, then sports medicine, then hopefully physical therapy, maybe limited physical therapy, maybe general physical therapy. I'm not sure just yet. ideally, Whoop, the company behind the bracelets, using their huge data set that they collect like anonymously in an anonymized way from the bracelets, they were able to do several very important papers and publish them in Nature that are actually kind of showing something, well, important, but also something that was kind of on the surface of things about how people live. So they show the correlation that, if you exercise before like very late during the day, then you're gonna have worse quality of sleep. Well, thank you, but now it's scientifically proved. So ideally, I would love to build a company that is able to do something in this realm, right? Tell people something new about their bodies, the thing that they are very kind of intimately kind of work with during like every day of their lives. But now there will be science behind that.
For me, this is a very interesting distinction between science and technology and publishing questions that we've already discussed. Because for sure, you're discovering a lot and you research a lot during building, and you want to understand things. But the way the society right now thinks about science, it's something quite different. It's all these people in universities who publish papers, and basically this gives me a very interesting question whether science has changed so much that it loses part of its goal of trying to not only understand, first of all, but to change the world. And we're now seeing how it's, well, maybe changing back once again, because, well, for trained scientists like we are, science is about publishing in Nature. Science is about going to conferences. But you're right now saying that science is about things that we can think of as technological things. And this, for me, is a fascinating and really under-discussed question of what science is, what knowledge is, what sharing of that knowledge is, and like the really overarching goals of these different venues. Do you have any thoughts about these differences between technology and basic science, fundamental science?
Yeah. Well, I don't have kind of, a formed thought around or like answer to my mind. This is something that I'm thinking about, but I find it like really, well, fascinating and maybe worrying myself that the biggest technological advancement that we had in the last decade, maybe ever, like AI itself, was driven not by academia. It was definitely driven by commercial companies. Like OpenAI is a commercial company. Everybody else, well, doesn't even, try to cover that. So the advancements were done not in a lab. The shift that I experienced, I saw, I think around like 2017, 2018, I started noticing that there are more papers coming from Google research or Microsoft research than from academia. Back at that time, like every morning, I would come to my work and then I would read all the papers from, like, I would skim through all the kind of names of the papers on arXiv that were published in the relevant sectors. And then I would read only the interesting ones. But then, like in 2015, it was mostly from academia. In 2018, it was definitely from the commercial companies.
Is it a good sign or a bad sign?
I don't know, right? It's just interesting, right? We don't think about science as something that comes from commercial labs. And it's also obvious that the science that comes from the commercial labs is kind of skewed towards earning money, right?
Before it came from the government, usually you had the atomic bomb from the government.
Even before that, it was just a personal, inquisitive, inquisitive nobleman paying for someone who is also inquisitive and who wants to do that. I mean, it's this switch between personal and societal in a way. It's like we're in a kind of a spiral about it here.
Yeah.
I like also that the AlphaFold was made by DeepMind.
Yeah.
So this whole field of biological scientists working with the protein folding, they lose the game to the Google at that point of time to DeepMind.
That's not the only way of looking at that, and biological scientists who work with proteins are not yet 100% convinced that like it is a huge deal, AlphaFold, but it's not a game changer. It was marketed to be. It's much more complicated. Well, unfortunately, it doesn't speed up other science of proteins as fast as you can think of if you just read the press release.
I like this idea that there is a gap between the adoption and the science, and there is this like rumor that next startup in Silicon Valley is usually just another service to deliver coffee or to make coffee or something about the coffee, because people who are doing these startups are usually people that consume, and the product they need is something closer to them. And this is also true for the machine learning, that the best application of machine learning, of AI that ChatGPT created, was right now the hugest driver is coding, because like this is something very close to what people who were inventing it are doing. So they understand the goal, they understand the problem, and we are now here. It's interesting to think like what if it wasn't like this? What if the people who were invented OpenAI were like biological scientists or other people, I don't know, like in other industries, maybe professional soccer players, I don't know. Maybe we will be in another world when squirrels are the secret government or something. Okay, it's from Rick and Morty. I mean, what do you think? Maybe we can fantasize a little bit about the world in several years, like how it will look like. Like, will we have just ChatGPT or something in our phone answering our requests, or will it be something more interesting? I don't know. Maybe not just generating kittens or.
Maybe we can focus a little bit more on the main topic, the computer vision. In several years, if some of the problems in computer vision are solved, how would the world change if the adoption is really fast?
Actually, what are the main problems of computer vision right now?
Also a good question.
Well, I would say the main, I probably am going to be repeating myself, but it's adoption. For sure, there are many problems that can theoretically be already solved, but there is lack of kind of, in computer vision, everybody is kind of sure that it's already automated. In the real industry, nobody knows about computer vision enough to actually understand, how to implement it. So there's we basically, I think, lack kind of these bridges between the industries. So the fact that there is going to be one industry where they're going to invest $500 billion kind of makes me sad, to be honest, because it again kind of sucks the brain power from everything else. Whereas to actually see AI implemented in like our daily lives, we need to have smart people, very evenly distributed across like waste collection, I don't know, making garments or like building houses. Then we are going to see real change. Because to be honest, like when do I use AI on a daily basis? I talk to my ChatGPT. I work with my research and my work like on the daily basis, but I suspect that I'm a minority in this sense. And that's it. I don't do anything else differently as compared to like 5 years back.
Writing writing letters became very simple, very quick.
But that's it, right?
Yeah.
The clothes are done the same way.
Mm-hmm.
The makeup is done the same way. We talk to our parents the same way, and we raise our children. it didn't change.
Well, but we let's wait. Let's wait a little more.
Yes, and to do that, to actually see the change in how the garments are made, we need product people who implement AI in this industry, right?
Yeah.
That's what I'm...
Maybe we'll see this talk part of implementing. So before it was implementing on devices, but here this TikTok,
Yes.
This TikTok movement will be a little bit different. Just it will take time to figure out where exactly it can lead to some changes.
Yeah. This talk, like previously, the algorithms were going on the devices, on the like edge devices, because it was adopting, like it was like the adoption was growing, and in many cases you just cannot, you know, always ask the server to recognize like the number for you, so you need to do it locally, and I'm sure that it's going to be the case.
Let's wait. It will happen soon. We will be in. We will not notice how fast it will change.
Yeah, maybe it will start from the local LLMs working for us, because right now I have some local LLMs, but I never speak to them. Usually because they speak Chinese better than English.
You know what? I use a local LLM like every day. I cannot work without it like ever. So I when I click a button, I just talk, and it turns it to writing. I convinced many people around me to do the same. It's like so incredibly fast, and it's local. So
you mean Whisper? I use Mac Whisper. The same
Mac Whisper,
thing. Yeah, good product.
It's like crazy how to make a really big company, a public company even, you need to change like a tiny portion of someone's day on a big scale. That's like crazy to think about, right?
Yeah, absolutely.
Like Calendly.
Like it's like. Yeah.
Let's try to change people's lives slowly, but...
Let's change people's...
We're in Cyprus, so slowly.
Yeah.
But slowly. I like it. Let's change people's way to live, but slowly.
Yes, yes, great.
Thank you for coming. It was lovely to hear you.
Thank you.
And,
Thank you very much.
I hope that we will have similar talk in several years and look...
with our 3D models in a really digitized environment where we can just sit in this very comfortable chairs.
And probably at that point of time we all perfectly speak Chinese.
We won't need that because the translation will be automatic.
Yeah, I am talking about this.
You know what? I bet that nothing is going to change.
Thank you.
Thanks.
Thank you.